Okay, this was requested, it's number 18 from one of the mock exams, and it says determine the area of the largest rectangle that has one side on the x-axis and two vertices on this thing. So these things pop up a lot. I've seen a bunch of these lately. Largest rectangle, it means area, and largest means I need to take the derivative and find the maximum area. So I'm going to have to come up with an expression for area. So the first thing I did in this problem was I went in and I graphed e to the negative x squared to see what that graph looked like. And I did, and there it was, and it's a little bump, okay? So in a bigger setting from my graphics calculator, and I'd write that down, I have this situation where maybe this is 2, and this is 2, and this is 1. And I have this function, which is y equals e to the negative x squared. And so I know my rectangle is going to sit in there because I want to take advantage of that hump there. And so these problems are all over the place. So this is what you have to do to find the area of this rectangle. You have to say, okay, well, this side is obviously going to be spaced equally around the y-axis because that's how I can get the highest rectangle. So I call this x, this distance here. So the distance of the whole side is 2x. That's one big thing. The next thing is this height. Well, that height is the y value that I take to get up to this, and this is that y value. So the area function for this rectangle here is base times height. Okay, this happens quite a lot lately. And so if I want to take the derivative of that and set it equal to 0, I have to do a u and a v. So let me just say this, finding a dash, right? So u equals 2x, so u dash equals 2. And v equals e to the negative x squared, so v dash equals just that, times the derivative of that, which is negative 2x. Okay, so my a dash equals u dash v 2e to the negative x squared plus that times that, which is negative 4x squared e to the negative x squared. Now, I need to factorize this to be able to set it equal to 0, and I can see that there's a 2e to the negative x squared in both of these, and that gives me 1 minus 2x squared equal to 0. Well, this can't be 0. That's not in the range of an exponential. And you can obviously see that, and you could make note of it, but this thing has, especially if I look at it from negative 1 to 1, negative 1, oops, to 1. Oh, well, that was really silly. Sorry, let me go out a little bit farther for you. Let's keep this at negative 5 to 5 maybe. Oops, no, still negative 1. The x value, we'll put negative 5 because I want to see how it's acting, to 5. You know, this thing is asymptotic and going along. Okay, so that's a really good picture of it. So I know that that is never 0. Exponentials have an asymptote. So 1 equals 2x squared, so x squared equals 1/2. So x equals plus or minus the square root of a half. Well, the square root of 1 is just 1, so it's 1 on root 2. All right, so I'm going to reject the negative answer because x isn't negative. And I'm going to say, okay, the other thing I need to do to prove this is a max is do a first derivative test. So I got an x and an a dash. And I know at 1 on root 2, the derivative is 0, so it's flat. So I might put in 0 as well. Okay, if I go up to my derivative up here, and I put 0 in, I get 2 times, I'll do it right here, I get 2e to the 0, well, e to the 0 is just 1, times 1 minus 0. So I get 2. So that's going uphill. And if I put in 1 here, I get 2e to the negative 1, well, that's just 2 on e, times by 1 minus 2. which is -1. So I can work that out. I did it on my calculator, and it turned out to be -0.7 something. So I know it's going down, and then I say, therefore, max at x equals 1 on root 2. Okay, and so in the problem, I wish I could remember, I think it just said determine the area of the largest rectangle. So let's do the area. So the area is going to be equal to 2 times 1 on root 2 times e to the negative root 2 squared. I'll pause and do that on my calculator. Okay, so I typed that all in, wacky stuff that it is, and I got area equals 0.86 about. And we'll put units squared. Okay, that's that.